Hey. Today we're going to be learning about 3.1, which is algebraic expressions. So, our learning target for today is going to be I will be able to simplify algebraic expressions. So, make sure that you have the title down in your notebook as well as the learning target. And as we follow along, feel free to pause, write down what I'm writing down, and get these down in your notes so you can use them to help you throughout this chapter. So first thing we're going to do is we're just going to define a couple vocabulary words. So the first vocabulary word that we're going to define is terms. And what is a term? We're going to define a term as a single number or variable, okay? And the thing about a term is they shouldn't be added or subtracted. So, for example, a term might be 3x. It also could be 4y. It could just be a number, 3. It could be negative 2x. Those are terms, okay? So single variables or numbers. A like term. So like terms are, sorry, I couldn't find my cursor, are terms that have the same variable raised to the same exponent. All right. So, like terms, you're going to be using this for the rest of your math career. So, we got to know what like terms are. So, remember, you 100% need to have this definition down in your notebook. It's the same variable raised to the same exponent. All right. So, same variable, same exponent. That is crucial for like terms. Then a constant. A constant is a fixed and well-defined number. Essentially, a constant just doesn't have a variable on it, okay? So examples of this could be 3, it could be negative 2, it could be 1/2, it could be 3.2. Those are ideas of constants. They're essentially just a number. And then finally, we're going to scroll down in simplest form. Simplest form is when an expression has no like terms and no parentheses, okay? So that is simplest form. So what we're going to do now, make sure you have these definitions down. And what we're going to do now is we're going to go look at some examples and we're going to use these definitions that we just wrote down and reference them. So make sure that you keep looking back up at the definitions to keep reminding yourself what they mean. All right, let's go to example 1. So example 1, identify the terms and like terms in each expression. Okay, so what we're going to do is we're going to have a couple key steps when we're doing these type of problems. The first key step is we need to identify terms, okay? But in order to identify terms, we need to rewrite as a sum of terms, and I'll explain what that means. So your first step, write this down, is going to be to rewrite as a sum of terms, okay? That's going to be your first step for both A and B, okay? So I'm going to do that. And what this means is we're going to write, okay, 9x. Then rather than writing the subtraction sign, we're going to go back to that 1.3 lesson where we learned to subtract integers. And remember, the rule for subtracting integers is to add its opposite. So essentially, subtracting 2 is just going to be adding negative 2, okay? So that's what we mean is rewrite as a sum. Sum means addition, which means we're going to rewrite it only using addition and then essentially adding its opposite. So 9x plus negative 2 plus 7. That's good. That's already addition. And then we have another subtraction sign. So again, we need to turn it to addition and then make that a negative x, add its opposite, okay? So this is how you would rewrite as a sum of terms. This is what you're always going to want to do before you identify your terms and like terms. So now we need to identify our terms. So over here, you're going to write terms, okay? And essentially, a term is the things that are separated by the addition signs. So 9x is a term. Negative 2 is a term. 7 is a term. And negative x is a term. Okay? So those are our terms. Rewriting as a sum helps us find those terms. So now what we're going to do is we're going to be using shapes to help us find like terms. So remember the definition of like terms has to have the same variable raised to the same exponent. So let's look here, okay? We have 9x. This doesn't have an x on it, so it's not a like term. This doesn't have an x on it, so it's not a like term. This has an x, and it doesn't have an exponent, which this 9x also doesn't have an exponent. So I know those are like terms. So to organize it, I'm just going to pick shapes. So I'm going to pick a square for my x-like terms, and I'm going to square them. Then I know that when I go down and I'm writing my like terms, I'm going to write down 9x and negative x. Those are like terms, okay? Now let's go do the other like terms. Well, remember the word constants. Constants, they don't have a variable on them, but any number, if they're, so negative 2 and 7, I'm going to draw circles around this. These are like terms because they're both constants. They don't have a variable, and essentially that's what makes them a constant. So my other set of like terms are just negative 2 and 7. So right there, that's how I find my terms, find my like terms. The first step always starts with rewriting it as a sum. So let's go over here to B, and we're going to try it one more time. So I'm going to rewrite this as a sum of terms, okay? So I'm essentially going to do that. So I have z squared plus 5z. Uh-oh, we have a subtraction sign here. So again, I need to add its opposite. So I'm going to add negative 3z squared plus z. Okay, great. I only had to make one little change. Now, let's identify the terms, okay? So come on down here, and we're going to identify terms. Well, again, the terms are everything that's in between the addition signs. So right here, we have z squared as a term, 5z is a term, negative 3z squared is a term, and z is a term. So now again, I'm going to get my shapes out in my different colors, and I'm going to identify my like terms, okay? So, So my like terms, oopsie, sorry, technical difficulties. Okay, so my like terms are going to be, well, okay, say I have z's, okay? But more importantly, I need to look at the exponents because remember, in order to be like terms, they have to be two things. They have to have the same variable to the same exponent. So I see this as z to the second power. The next term, 5z, it doesn't have an exponent. So therefore, those are not like terms, okay? But over here, I see I have a negative 3z squared. Now these, I'm going to draw a box around them. They have the same variable and they are raised to the same exponent. Therefore, those are like terms. So I'm going to write down z squared and negative 3z squared, okay? Now, my other set of like terms are going to be, well, I have a 5z, so z again, and then I just have a z. Again, same variable, raised to the same exponent. If they don't have an exponent, we can just assume they're raised to the first power. Okay, so my other set of like terms are going to be 5z and just a z. All right, so again, those are my like terms and my terms. First step, always rewrite as a sum of terms. Okay, make sure you pause, get all this information down, and then you can scroll on to the next example. All right, so next we're going to look at simplifying an algebraic expression. Okay, so we're going to focus on simplifying the algebraic expression. We're going to do it step by step. So write down all these steps in your notebook. So the first step is going to be the same as the above example. We're going to rewrite as a sum. Okay, so I'm going to rewrite this as a sum. 3 over 4y plus 12. That's fine. It's an addition sign. We have a subtraction sign. So again, we're going to add its opposite. So plus negative 1/2 y. We have another subtraction sign. So again, we're going to add its opposite. Add negative 6. Okay? That's rewriting it as a sum. Rewriting it using only addition. Okay, next step. I want to identify my like terms with those boxes, those squares and circles so that I keep it all organized, okay? So I see a y here, and then I also see the negative 2y. So I know that this is the same variable raised to the same power because it doesn't have an exponent. So these are like terms. And then I also see that I have some constants. And remember, constants are just numbers that don't have variables attached to them. So these are constants, and I know that those are like terms as well. Okay, so now I have my like terms. And the reason that I want to make it very clear what my like terms are is because I want to keep them organized. I can only add and subtract like terms. You cannot combine things that are not like terms. So that's why it's so crucial to identify those and know what they are. Okay, one sec. I'm just going to delete this real quick. Okay, so our next step is going to be to rearrange using the commutative property. So write that step down, please. Rearrange using the commutative property of addition. Okay. So what that means is I'm going to rearrange it because remember with addition, order does not matter. So I'm going to rearrange them to put my like terms next to each other. So essentially what I'm going to do is I'm just going to write 3 over 4y. Then next, rather than writing that plus 12, I'm going to write the plus negative 1/2 y because I want my like terms together. Then I can put my other set of like terms, the 12 plus the negative 6. Then remember, if we're keeping it all consistent and drawing those boxes to help keep track of everything, you can see I have my like terms together and then the constants are together. Okay, so we're keeping it all organized next to each other. Now, our next step in simplifying is we need to pull out the y using the distributive property, which we should have seen in 6th grade. Okay, so the reason we're going to pull out the y is so that we can deal with those numbers, the coefficients, so the numbers in front of the variables, without having to worry about the variable, which is the y. So what you're going to do is we are going to write, okay, right here, 3/4. You need the parentheses, plus the other coefficient, negative 1/2 y, and that, and then the y goes outside of that. So remember with distributive property, if you have a number outside of the parentheses, essentially that thing outside the parentheses gets distributed to both of those, okay? So by pulling out the y, we're not changing anything. We're just, frankly, putting the coefficients together so we can work with those numbers first. So remember, we want to keep all of our like terms very organized. So again, these are like terms, so we're good. And then we have plus 12 plus negative 6. All right. So keep scrolling down. The next thing we're going to do is, and don't forget, our constants are also like terms, 12 and negative 6. So now our 4th step is going to be to combine like terms, okay? So combine like terms. So what that means is we need to add those two fractions together. So I'm going to write this very clear so we know what we're doing. 3 over 4 plus negative 1/2. Now, what we need to do in order to add 3/4 and negative 1/2 is, what do we need if we're adding or subtracting fractions? We need a common denominator. So I'm going to multiply the bottom and the top by 2, okay? And then we just want to keep our work very clear. So we're going to write out the rest of the expression. Then if you look up here, 12 plus negative 6, well, I know from chapters 1 and 2 that 12 plus negative 6 is going to give me 6. Okay? So now let's move down and do this fraction addition. So we have 3/4 plus negative 1 times 2 is going to give me 2. 2 times 2 is 4. Okay? And then we have y plus 6. We're making our work very clear. Remember, this is how we're going to have to show it in the big ideas assignments. Then finally, we have the same denominator, so let's put the numerators together. 3 plus negative 2 over 4. Y plus 6. And then finally, I know that 3 plus negative 2 is just going to give me 1. So that's going to be 1/4. And then my y plus 6. And then I can just write this as, I can take out the parentheses now that I've simplified those coefficients, and I can do 1/4 y plus 6. And then you still want to note that we still have both the box and the circle. This is a good check at the end of simplifying expressions to make sure that you have not combined any numbers that are not like terms. All right, so that is the step-by-step process for how to simplify an expression. Make sure you have this all down in your notebook, and then we will work on the big ideas assignments in class tomorrow. All right, nice job.